Good day everyone. For our second topic, we would be discussing pumps part 1. So what is a pump? A pump is a mechanical device used to lift water from a lower elevation to a higher elevation, or from a lower pressure to higher pressure, or same pressure. Sometimes it's also used to increase the volumetric flow rate or allow water to flow. So, what are yung water factors? So when we say, total dynamic head. When we say total dynamic head, this is the sum of all of the required head. The pressure head, the velocity head, the friction head, and the elevation difference. So, total dynamic suction lift is applied to pumps handling cold water, while net positive suction head is the difference between the absolute dynamic pressure of the liquid measured at the center of the pump center line and the saturation pressure corresponding to the temperature of the liquid. At the same point, all expressed in terms of feet or meters of the fluid. So, kapag water siya, meter or feet of water. Pero kapag sinabi nating oil siya or fuel, ganun din. Halos lahat naman na to, ganun lang din ang pag-express in feet or meters. Depende kung anong fluid ang kino-convey niya. Okay, so yung meron tayong developed head, it is the difference between the sum of the absolute pressure head and velocity head over yung ganun din, pero ano siya, inlet tsaka outlet, yung part na to. Then meron tayong static head. Ito yung height nung buong pump. This is the height of the surface above the water and the gauge point. So ayun nga. Pressure head is the static head plus gauge pressure on the water surface plus friction head. While velocity head is the required power in meters or feet na nare-require ng specific fluid to flow in that specific volume or volumetric flow rate. Pag sinabing suction lift, ibig sabihin nun, yung pump is above the water. So above siya ng water. Tapos kapag sinabing suction head, yung pump naman natin is below ng water or source of water. Then there's static discharge, which is the vertical distance from in meters or feet between the pump center line to the point of free discharge. So, let's say nandito yung pump. Imagine niyo lang, nandito yung pump. Tapos nandito yung yung discharge. Ito yung center line. Kapag sinabi mong yung total distance, ito yon. Pero kapag sinabing yung static discharge head, ito lang yon. From center papunta sa discharge.
Total static head, HS. The vertical distance in feet meters between the liquid level of the supply and the point of the free discharge on the surface of the liquid in the discharge tank. Friction head, or the FI. The head required to overcome the resistance to flow in the pipe and fittings. Total dynamic suction lift is the static suction lift plus the velocity head at the pump suction flange or flange plus the total friction head in the suction pipeline. Total dynamic suction head is the static suction head minus the velocity head of the pump suction flange minus the total friction head in the suction pipeline. Total dynamic discharge head is the static discharge head plus the velocity head at the pump discharge flange plus the total friction head in the discharge line. And the capacity is the rate of flow of fluid measure per unit time, usually gallons per minute, or the GPM, or liters per minute, LPM. Centrifugal pump. A pump in which the pressure is developed principally by the action of centrifugal force. And suction pump is a single suction pump having its suction nozzle on the opposite side of the casing from the stuffing box of having the face of the suction nozzle perpendicular to longitudinal axis of the shaft. Inline pump, a centrifugal pump whose drive unit is supported by the pump having its suction and discharge flanges on approximately the same center. Horizontal pump naman ay a pump with the shaft normally in horizontal position. Then, vertical shaft turbine pump, a centrifugal pump with one or more impellers discharging into one or more bowls, and a vertical educator or column pipe used to connect the bowls to the discharge head on which the pump driver is mounted. Booster pump is a pump that takes suction from a public service, main or private use water system of the purpose of increasing the effective water pressure. Submersible pump is a vertical turbine pump with a pump and motor close and designed to be installed underground. As in the case of the deep well pump, horizontal split case pump, a centrifugal pump characterized by a housing which is split parallel to shaft drawdown, the vertical difference between the pump water level and the static water level. Then, static water level naman is the level with respect to the pump of the body of the water which it takes suction when the pump is not in operation. Then lastly, pumping water level, the level with respect to the pump of the body of the water from which it takes suction when the pump is on operation.
So, ang next natin is ang pump formulas. So, first in the list is ang volume flow rate or the pump capacity. It's denoted by the symbol Q. So, it is equal to the area times the velocity. Kasi kapag may area, para is meter squared, times mo siya sa velocity na meter per second, magiging siyang equals meter cube per second, which is the volume over time, volume flow rate. So, ang next one natin is yung total dynamic head. So, ang total dynamic head naman is denoted by symbol H. Yan. H. So, ang total dynamic head, kagaya ng nabanggit kanina ni AJ, it is the composition or the totality or the sum of the pressure head, velocity head, yung Z or the elevation, and the friction head. So for the pressure head, we have the pressure of the discharge minus the pressure of the suction over the gamma of the fluid, or which in our case is the water. So plus the velocity head or the velocity sa discharge squared minus the square velocity of the suction all over 2GO. So plus the elevation of the discharge minus the elevation of the suction. So take note din pala na kapag ang suction natin ay vacuum, magiging negative siya. So magiging for example, diba minus ZS, kung minus na, kung vacuum siya, magiging minus ZS din, kaya magiging plus na rin siya kapag nag-derive na yung formula. So, for our friction head naman, kapag there are two formulas for the friction head, for using Darcy's equation, we have friction head equals the friction coefficient times the length of the conduit times the velocity squared all over 2GO times the diameter. So, ang GO pala is yung gravitational pull or the original gravity, which is the 9.81 if not given. So, if using the Morse equation naman, we have friction head equals to 2F or friction coefficient times the length times V squared all over the gravity times the diameter. So, dito pala, kung makapansin mo, ito ang ating pressure suction pressure and discharge pressure para sa pressure head, and sa velocity naman, ito, and this one, discharge and suction. So, sa CD is yung, kung mapansin natin, is yung elevation niya from the center line to the discharge. And the ZS is the elevation ng center line, then and the height of water. So next natin is the hydraulic or water power. So the water power or WP is equal to gamma times the volume flow rate times the total head. And for our pump efficiency, we have, it's denoted by N sub P for the pump, P for the pump. So for pump efficiency, we have water power and the brake power. So ang brake power, ito yung power na galing sa kanyang motor or actuator. So for the motor efficiency naman, which is denoted by N sub E, or is equal to BP, which is ang kanyang output, and the EP naman is yung input. And for the overall efficiency, we have the N sub O, because overall, and it is equal to WP all over EP. It is derived by multiplying the pump efficiency and the motor efficiency. So like this, we have NP times NE, magiging ano siya, WP time over BP times BP all over EP. So cancel, gawa natin ng WP over EP, same sa overall efficiency natin. So ang next naman natin is yung problem solving na.
Okay, so for our first problem, ang problem natin is a pump delivers 100 liter per second or equivalent to 0.1 cubic meter per second of water at a head of 50 meter. Find the water power. So WP or water power is equals to gamma ng H2O kasi water. Tapos yung ating velocity, yung ating volumetric flow rate, which is ito, equivalent lang siya sa 0.1, and ang ating head. Yan lang yan. So it's equal to 9.806 times 0.1 times 50 is equals to 49.03 kilowatts. Yan. Ganyan lang siya kasimple. Direct substitution lang. And for number 2, ito medyo mahaba. Kasi ito, gagamit na tayo ng formula ng TDH. Meron ditong kailangan burahin. Basahin natin problem course. A centrifugal pump delivers 227 cubic meter per hour of water from a source 4 meters below the pump to a pressure tank whose pressure is 2.8 kg per centimeter squared. Friction loss estimates are 2 meters suction line and 1 meter at the discharge line. The diameter of the suction line is 250 mm and at the discharge is 200 mm. Find the kilowatt rating of the driving motor of the pump, which has an efficiency of 70%. So, para makuha to, ang angin natin is BP. That is BP. It's unknown. So, meron tayo nito. So, water power over yung ating efficiency. Or, yan, efficiency. Yun lang yan. Tapos, ang water efficiency natin is 0.70. Wala pa tayong water power. Ang water power is, yung matulog discuss kanina, gamma of water multiplied by speed and head. Kaso dito, yung head natin is medyo hiwa-hiwalay din. So, ang formula of head is equals to P2 minus P1 over gamma of water plus V2 squared minus V1 squared over 2GO. Then, meron pa, marami pa yan. Mahaba yan. Wait lang. Try muna natin. Hindi kasha. Wait lang. 2GO. Then, sa taas niyan, well, hindi sa taas technically, meron tayong yung ating frictional losses plus yung ating elevation. Depende kung gaano ka na taas or gaano ka baba, it's always minus or plus. So, ito yung elevation. Tapos ito yung frictional losses. F plus F lang yan. So, ang una natin kailangan kunin dito is kailangan natin kunin yung head. Eh, wala tayong volumetric, wala tayong velocity, kumbaga. Pero binigay sa atin ang diameter ng pipe sa inlet at outlet, which is this and this. So, given this, ko-convert natin siya muna into meters. Then, ang formula lang niya is same lang din. V is equals to 4 pi d squared times 1h over 3600 seconds para may seconds lang siya. So, same formula lang yung gagamitin natin. Lumalabas ang ating V1 is equals to 1.2846 meter per second. Kasi cubic meter, cancel this. Ito magiging 36 pa, 36 seconds. Yan. Then next, para makuha naman natin yung pangalawa, same process lang. 4 multiplied by 227 times 1 over 36 over pi multiplied by 0.2 squared equals, iba na natin sa part na to, 0.2. Lumalabas na 2.0071 meter per second. So meron na tayong yung inlet at outlet velocity. So since nakuha na natin yung inlet and outlet velocity, pwede na natin itong insert sa ating total head equation. Pero based sa analysis natin, meron na tayong given na pressure. Itong pressure lang na to, ito. So a-assume natin na P2 or P1 is non-existent. In this case, it's P1 is non-existent. So P2 lang siya. Kasi yun lang ang pressure niya. Wala siyang isang pressure na iba. So lalabas dyan, head or H is equals to 2.8 kilogram per centimeter squared. Ko-convert pa natin to. Multiplied by 100 squared centimeter over 1 meter para ma-cancel out yung centimeter squared. Cancel out na yan. Over 1,000. Kasi density of water. Plus yung ating dalawang velocity head, yung V2 muna. 2.0071 squared minus 1.2. So lumalabas ng ating head is equals to ating head or H is equals to 35.1213 meters. So yan, given na yung head natin, pwede na natin itong insert. Nakuha na natin yung head natin, pwede natin siya So yan, insert na lang natin. So, meron tayong 9.806 multiplied by yung ating velocity na 227, then multiplied by 35.1213. Malabas ang ating water power is equals to 21.7163 kilowatts. Ngayon, divide na lang natin to sa 0.7 para makuha natin ang ating motor power or brake power. Divide na natin siya sa 0.7. Lumalabas ang ating motor power is equals to 31.0233 kilowatts.
Open reservoir B. Suction and discharge pipes are 150 mm and 100 mm in inside diameter, respectively. The loss of head in the suction line 3 times the velocity head in the 150 mm pipe, and the loss of head in the discharge line 20 times the velocity head in the 100 mm pipeline. Water level at reservoir A is an elevation 6 meter, and that of the reservoir B at elevation 75 meters. Pump's center line is at elevation 2 meters. Overall efficiency of the system is 73%. Determine the power input of the motor if the capacity is 10 liters per second. Okay, so given. Our given is we have diameter is 150 millimeter and D2 100 millimeter. Then we have friction loss, which is 3 V1 squared all over 2 GO. Then friction loss 2 is 20 V2 over 2 over 2 GO. Then our elevation is 6 meters, then Z2 is 75 meter. Then we have ZP or the CL. CL is equals to 2 meters ZP na guys. Then efficiency is 73%. Then volume flow rate natin is 10 per second. Rectangle na guys conversion 1,000 liter is equals to 0.01 cubic meter per second. So ang hinanap natin is ayan, screenshot nyo muna guys. Okay, delete ko na cache. Then kunin muna natin yung volume. V is equals to Q over A, then Q by T2 over 4. So magiging 4Q all over by D2. Then V1 ay 0.01 cubic meter per second all over by 0.15 cubic meter. So cancel na yung cubic meter. Boom. So ang answer dito ay 0.5659 meters per second. Then V2, ang V2 naman ay 4. So solve na natin. Okay, ano ba? 10P is equals to YQH over efficiency. Then YQ P2 minus P1 over Y plus V2 squared minus V1 squared over 2GO plus our elevation 2 minus ZP minus elevation 1 minus ZP ulit. Yun na sa formula plus friction loss ng FL1 plus FL2 all over efficiency. Okay, drag natin is equals to YQ V2 squared minus V1 squared all over 2GO plus elevation ng Z2 minus Z1 plus 3V1 squared plus 20 V2 squared all over 2GO plus parenthesis 1 all over. So, balikat ko, efficiency. So, next, derive ulit natin yan. YQ 21 V2 squared plus V1 squared all over 2GO and plus elevation ng Z2 minus Z1 close parenthesis 1 all over efficiency. So screenshot nyo muna ulit guys. Di kasya. Hindi, try natin. Sige. Magkasya. Is equals to ano yan? 9.806 Newton cubic meter 0.01 cubic meter per second. Tama ba ito? 21 yung B2 natin 2732 and squared minus squared second squared plus 2 B1 natin is 0.5659 sorry 9 close squared and 2 second squared then close parenthesis natin na guys all over 9.806 meters per second squared tapos plus 75 minus 6 meters which is yung elevation natin nilabas then all over 0.73 yan. So ang MP natin ay MP. So ang sagot natin ay 9.5062. Yan. Ang sagot natin.
Let's move on to the next problem. So, a 4 meter cube per hour pump delivers water to a pressure tank. At the start, the gauge reads 138 kPa o kilopascal until it reads 276 kilopascal, and then the pump was shut off. The volume of that tank is 160 liters, and at 276 kilopascals, the water occupied 2/3 of the tank volume. So the question is, determine the volume of water that can be taken out until the gauge reads 138 kilopascals. So, first, sulat muna natin ang mga given. So, ang una natin is the 4 meter cube per hour. It is simply the volume flow rate or meter cube per hour. So, ang next natin is delivers to a pressure tank at the gauge reads until. So, ang P gauge natin na panguna or 1 is reads at 138 kPa until it reads. So the second one is 276 kilopascals, and then the pump was shut on volume. So ang total volume daw ng tank natin is, let's denote the volume of tank as V tank or T plus 160 liters. So, ang sabi, at 276 kPa, the water occupied 2/3 of the tank. So at 276, ilagay na lang natin dito. So, yung water daw, volume ng water is equal to 2/3 of the volume ng tank. So, ang hinahanap is determine the volume of water that can be taken out until the gauge reaches 138 kPa. So, ang hinahanap natin dito ay ang volume removed, or equal dito sa B W2, volume water na removed, BW1. So, para masolve natin ito, gagamitin natin ang equation ni Boyle's law, or P1 V1 is equal to pressure ng second state and the volume of the second state. So dahil hinahanap natin dito makuha natin ang BW2, makuha natin dyan, kailangan natin ang BW1. So para makuha BW1, pwede siya sa B1. So sa Boyle's law, derive mo natin siya in terms of B1. So P2 over V2 all over B1. So ayan, solve muna natin yan. So kung mapapansin nyo, sa given natin is gauge pressure ang given. So, kailangan kunin muna natin ang absolute pressure. So, for the P1 is equal to P atmosphere plus P gauge. So, equals to 101.325 plus 138 kPa. Kaya ako ginamit ang 101.325 kasi same na siya ng unit sa given natin na 138 kPa. So 101.325 plus 138 is to 39.325 kPa. So for our second pressure, or the pressure to ganun pa din, PPTM plus the gauge pressure sa 2 is equal to 101.325 plus 276 kPa. So 101.325 plus 276 is equal to 377.325 kPa. So meron tayong P2 at walang P1. So sa B2, sa B2 naman makuha sa BW2. So kunin muna natin ang BW2 na 2/3 daw ng 160 liters. So kung sunod natin yan, 2 times 160 over 3. Mas din ay 106.666. Let's keep it sa 4 decimal places. So meron tayong BW2. So para makuha natin ang B2, so makuha natin siya sa volume ng tank, which is equal siya sa, of course, sa volume ng water plus sa volume ng air. Siyempre di ba sa tank, if meron siyang, kung halimbawa, this is the tank, may yung tank. Tapos kung halimbawa may water dito, ito ang ating B, yan ang ating BW, ang volume ng water, and dito naman is yung volume ng air. No, yan, parang ganyan siya. Kaya total volume equals sa volume ng water 2 and of course volume ng air at second state. So para naman sa ating V2, pag dinerive na siya is, wait pala natin siya. So V2 equal to VT minus VW2 is equal to 160 liters minus 106.6667 liters equal to 160 minus 106.667 liters is 53.3333 liters. So meron tayong P2, V2, and P1. So substitute na natin ang mga nakuha nating sagot. So for our P2, we have 377.325 kPa times ang V2 na 53.3333 liters all over P1 na to 39.325 kPa. So cancel natin yung kPa kasi same sila. So 377.325 times 53.333 all over 239.325 is equal to sa 84.0864 liters. So meron tayong B1. So ang hinahanap dito ay PR. So kulang pa rin tayo ng BW1. So para naman sa BW1 para lang siyang galing sa, pwede siya same siya dito sa equation na yan. So pag dinerive is BW1 is equal to VT minus B1 equal to 160 liters minus 84.0864 is equal lang siya sa 75.9136 liters. So, meron tayong BW1 din. Solvable ng VR, or the water remove, or to be taken out, so that the gauge will weigh 138 kPa. So, VR is only BW2, which is, consider na natin, is 53. Sorry. BW2 is 106.6667 minus 75.9136. So, equal siya sa 106.6667 minus 30.7531 liters. Yun ang ating final answer. So, 30.7531 pwede siya dito sa 30.75 na pinangmalapit. The answer is A. Ganun lang siya. So, ang next naman natin is next problem is a sharp-drain pump is used to deliver 150 gallons per minute of water having a relative density of 0.9803. So, the suction and discharge gauge reads 4 inches mercury vacuum and 25 pounds per inch or psi respectively. So, the discharge is 2 feet from the pump center line. And what is the motor output if the pump is back efficiency is 75%? So, first, tuloy mo natin ang mga given. So, deliver daw ng 150 gallons per minute. So, ang relative density natin, or ang SG, is 0.9803. The suction naman, discharge, suction is the T1 is equal to 4 inch ng mercury, which is vacuum. And the 25 psi is the P2. So, the discharge is 2 feet from the center line. Sa discharge naman, sa elevation natin is 2 feet daw from the center line. So, what's the motor efficiency pump is? The motor efficiency 75. Okay. Wait. Ang motor daw ay, ang pump efficiency daw pala natin is 75%. Ang hinahanap naman is the motor power, motor outputs, which is the BP or the brake power. So ayan. After nyan, syempre, ang formula natin for efficiency naman ng pump is the input over output ng pump, which is input natin is the water power, of course, while the output is the yung galing sa motor na brake power. So from that, we can denote that the brake power is equal to water power over pump efficiency. So meron tayong efficiency, so sa WP, kunin naman natin ang WP. So for the WP, we have gamma Q height or gamma times volume flow rate times the head. So sa Q, meron tayong Q. Sa head naman, wait, pwede pala natin unahin ng Q. Lagay sa gilid kasi nakagalon siya. Gawin na natin gallon per minute. Gawin natin siyang meter cube or dahil naka-English, feet cube. So, ang ating 1 feet cube is equal to 7.481 gallon. So, 150 per is equal to 20.22022211 feet cube. So, ayan. So, sa head naman, so check na to. Sa head naman, we have the pressure head plus the velocity head plus the elevation head plus the frictional losses. So, dito pala may nakalagay tayo discharge from 2 feet center line ANI. So, discharge the elevation from the second state is 2 feet. Yan. So dahil na tayong given ng velocity, so wala rin tayong diameter, wala tayong pagkukuha ng velocity. This is as good as cancel or zero. Z1, wala rin tayong Z1, and the frictional losses. So kukuha tayo ng head sa pressure and sa Z2 or sa elevation. So for P2, we have 25 psi pounds per square inch minus the P1 na 4 inches, or gusto mo nyo ba na i-gano na siya. So ayan, dahil para di mahaba sa pinaka-solving, hiwalay na natin siya ng solving. So sa isang inches ng mercury, it's 29.92 if I'm not mistaken, sa 14.696 na PSI. Calculate natin for 0.696, 29.92. Ang lalabas ay 1.9647 PSI. Dito is 1. So dahil makita nyo vacuum, so kapag vacuum, take note lang, is magiging negative siya. Kaya negative 1.9647 pounds per square inches. All over. So y natin na 62.427 pounds per cubic foot. So plus Z2 na 2 feet. Sikuha siya sa 5 minus 1.9647 62.427 plus 2 feet. So ito pala, wait, nakalimutan pa tayong gawin. Easy convert ang inches sa cubic foot sa foot. So 144 or 12 inch, 12 squared is 144 or 1 foot square. So cube squared cubes, inches squared, sorry. So pounds cancel. Feet squared, feet lang matitira. So ang sagot natin is times lang natin siya sa 144 in 64.199. Oh wait, may SD pala tayo na 0.9803. So, sorry. So may siyang 65 point. Kaya 9 point kasi hindi 1 ang SD niya, kaya hindi constant na 1 yung, or yung density niya is magbabago. 65.4493 feet. So meron tayo H. So galing tayo sa main equation natin na BP. So WP, gamma natin is 62.427 times ay pound per cubic foot. Siyempre times pa rin natin sa 0.9803 na relative density. So times sa QH. So Q natin na 220.2211 feet cube. Times natin sa H natin na solve natin na 65.4493 feet. All over sa NP natin na 0.75. So solving. So 280.2211 is 5.4493.75. So ang lalabas dyan is 107,989. Pero pwede naman natin siya dire-diretso na divide sa 33,000. Kasi Kasi kailangan natin is from the choices na HP, di ba 33,000, yung mag-equal siya sa so, kung siya mag-cancel, minute, fit, pound, tira yung HP, pupunta sa taas yan. So, lagi tayo 3.27 HP. Yun ang ating final answer. Yan, which is ang pinakamalapit ay ang 3.24 HP, not A. So, that's all. Thank you. God bless.